The Physics of Life, Addition versus Multiplication Part 1, number 1643, 5/15/2026, Gerald C. EclaireMD Foundation, Category, Self-Reflection, Learning and Life Philosophy. Preface, today at approximately 5 a.m. in Honolulu, Hawaii, I briefly woke up from sleep and then fell asleep again, during that final hour of sleep. I had a vivid dream regarding one of my old undergraduate classmates from Iowa during 1969-1970, who later went to mid around the same time as me in 1972. I majored in mechanical engineering and took additional graduate courses in both aerospace engineering and electrical engineering and computer science, with emphasis in AI-related courses. However, he focused primarily on fluid dynamics within aerospace engineering. The dream itself was not imaginary because the actual story truly happened about 50 years ago. However, inside the dream, my brain was trying to simplify and understand the deeper meaning behind the very different life trajectories between the two of us. After waking again around 6 a.m., I spent nearly 20 minutes discussing this physics concept and life trajectory analogy with an AI tool, attempting to find the clearest and simplest possible explanation. At first, I tried using the example of air conditioning systems connected in parallel addition effect versus series multiplication effect. However, that air conditioner analogy quickly became confusing because physical engineering systems for air conditioners use different units and obey thermodynamic energy laws. Eventually, after several back-and-forth discussions, both AI and I finally understood and agreed what I was truly trying to describe. I was not discussing physical theories of power efficiency, engineering wattage power equals voltage times current, or installation differences among various air conditioning units. I was merely trying to compare the parallel style addition effect versus the series style multiplication effect of human life trajectories, endpoints, and long-term accomplishments. This realization actually summarizes much of my own life experience over the past 79 years. The story of two classmates back in the early 1970s, one of my undergraduate classmates at the University of Iowa and I both entered mid around the same time in 1972. My classmate was academically intelligent, but not sufficiently wise regarding long-term real-life judgments and trajectory decisions. He later completed his PhD in aerospace engineering relatively quickly. His academic path was highly focused, efficient, and specialized. After graduation, he joined a major aeronautical engineering company and later transferred to another equally famous aerospace company. With a better annual salary, he eventually became a senior engineer and later a technical fellow-level professional. This was already a highly successful and respectable engineering career. However, my own path gradually became very different. I took longer to finish my studies because I absorbed knowledge more slowly and more deeply, meanwhile maintaining a broader range of interests. I was never interested in simply finishing courses quickly. I wanted to understand the deeper structure behind the knowledge itself. At the same time, I gradually discovered that different academic fields were not isolated from each other. Instead, they continuously interacted with and reinforced one another. Over the next 6 decades, I continuously expanded into many additional academic disciplines, including applied mathematics, physics, engineering, computer science, artificial intelligence, business management MBA studies including sales, marketing, economics, and finance, plus 9 years of self-study in psychology and personality disorders, and 17 years of self-study in pathophysiology, general health including food science, behavioral science and eventually biomedicine, and various mortality diseases. In engineering alone, I studied mechanical engineering, computer science, and biomechanics at University of Iowa, fluid dynamics and ocean engineering at Stevens Institute of Technology, bridge design at Columbia University, and civil structural engineering plus soil mechanics at UC Berkeley. In total, I have spent 44 years of my adult life studying, including 18 years on 7 campuses earning 6 degrees, plus 26 years of self-study at home across a total of 12 academic disciplines. That is why I call myself a professional student, even now, at age 79.5. I still read textbooks and published academic research papers every day. At the same time, I worked with extremely high intensity for decades. Since I moved to the Bay Area Silicon Valley, during many different periods of my career, I worked around 100 hours per week continuously for 50 years. Approximately 20 years later, sometime in 1995 after the initial public offering IPO of my successful semiconductor integrated circuit IC chip AI design software company on NASDAQ Avant. Now part of Synopsys, my old classmate at both Iowa and MIT and I met for lunch together in Silicon Valley. During that conversation, he asked me a direct question regarding my annual salary. At that time, my annual compensation as a public company CEO was approximately $8.3 million in salary alone. He became shocked because his own annual salary was approximately $83,000, and he had always been very proud of his academic and professional accomplishments. He then asked me, "How can that happen? That is not fair." I answered him honestly. I told him that he had become an excellent specialist in one field, while during those same 20 years, I continuously studied many fields while simultaneously pushing myself far beyond normal working intensity. Then I told him something that remained deeply inside my mind for many years afterward. Your academic and professional growth was mostly additive, then became multiplicative through my life. My classmate chose the low-risk, stable path of an employee. I chose the high-risk path of an entrepreneur founding an IC chip software company. In the physics of finance, risk and return are inextricably linked. My multiplicative rewards were also a function of the asymmetric risk I accepted. Addition versus multiplication. For many years afterward, I continued thinking about that simple sentence because it captured a very important difference in life trajectory. Many people experience mostly additive growth. They learn one skill after another, accumulate one credential after another, or perform one task after another. The process resembles simple addition. 2 plus 2 plus 2 plus 2 equals 8. The total becomes larger, but the components remain relatively independent from each other. This was similar to my Iowa undergraduate classmate's approach, where he rushed through multiple courses in parallel, producing primarily an addition effect rather than a deeply integrated multiplication effect. However, some forms of human development behave very differently. In reality, the neuroscience structure of the human brain itself behaves more like a multiplicative interacting system. Largely speaking, above statement is conceptually correct from a neuroscience and systems perspective because the human brain functions through highly interconnected, nonlinear, and reinforcing neural interactions rather than through simple isolated additive processes. When different disciplines, experiences, skills, and efforts continuously interact with and reinforce each other over long periods of time, the effect becomes nonlinear and multiplicative. 2x2x2x2 equals 16. The comparison between multiplication versus addition is 16/8 equals to. This was closer to my own life experience and approach. I patiently added courses one after another instead of rushing into parallel processing. My learning process followed more of a series structure, where each discipline reinforced and amplified the next one, gradually creating a multiplication effect over time. Of course, these numbers are symbolic only. I am not discussing literal arithmetic. I am describing the concept of compounded multiplication effect on human capability, long-term learning, productivity improvement, and life potential. For example, mathematics amplifies physics because mathematics provides the language of structure and abstraction. Physics then amplifies engineering because engineering converts physical principles into real systems. Engineering amplifies artificial intelligence because systems thinking and optimization become transferable. Artificial intelligence amplifies business strategy because pattern recognition and prediction become useful in management and market competition. Psychology amplifies leadership because understanding human motivation changes organizational effectiveness. Medicine amplifies human understanding because disease and suffering reveal deeper truths about biological systems and life itself. The above paragraph has essentially described my adult life journey and the multiple interrelated accomplishments toward my life purpose. Actually, my life purpose is very simple: continuously learn new knowledge and then apply that knowledge to create useful products, systems, or programs that can serve human society. When these different domains continuously interact with one another over several decades, the final effect becomes far greater than simple addition. This is similar to compound interest in finance. Small differences during the early years may appear insignificant, but after enough time passes, the trajectories diverge enormously. This is part 1.